Welcome back to this video series on the topic of fantastical factorization. Chapter B, Sum and Product. In this lesson you will learn how to factorize second order expressions using the sum and product method. A second order algebraic expression is typically of the form ax squared plus bx plus c, where a, b and c represent numbers. This is also called a trinomial expression because we have three terms within the expression, so 1, 2, 3 meaning tri. A trinomial may be factorized into the form x plus alpha times x plus beta. The way in which we're going to learn how to do that today is called the sum and product method. Let's have a look at how this can be done. Example 1, factorize the following expression. We have the expression x squared plus 9x plus 20, and we want to factorize this such that it's going to be of the form x plus alpha times x plus beta. Now the way in which this is going to be done is using the method called the sum and product method. The way in which this works is we are going to split the middle term in the trinomial. So we're going to get x squared plus ax plus bx. After which we're going to factorize such that we get something of the form x times x plus beta plus alpha times x plus beta, where you can see that we're able to do our factorization. So you've got two common factors, x plus beta, which go down here, and the leftover x plus alpha, which go over here. So it's a bit of a long process. Now, the way in which we determine the numbers for a, b, alpha, and beta is using the sum and product method, where you might be able to tell already that a and b sum together to give 9, but they also multiply together to give 20. The real challenge here is figuring out the numbers for big A and big B. Now, setting ourselves up, what I like to do to figure out these numbers is I rule off a little section of my page and I ask myself the question, what two numbers sum to 9 and multiply to give 20 in this instance? So 9 coming from here, 20 coming from here. Now, looking through how I do this, I start off in a bit of a methodical manner where I'll go 9, and two numbers I can start off with is 1 plus 8, so that's going to sum to 9, and then I change it to times, so 1 times 8 is 8, and then I slowly work my way down the numbers. So 1 turns into a 2, and 8 goes down by 1 to a 7, and that goes 14. And what I'm looking for are two numbers here that will sum to give 9, so these will always sum to give 9, but I'm waiting for this to turn into 20. So I just work my way down until finally I find my way. So it can be seen that my big A and big B are 4 and 5 in any order that I wish. So modifying this, what I can say is that 9 can be split into 4x plus 5x. Okay, I'm now ready to start the factorization process. What I'm going to do is I'm going to break these two, or this large expression, up into two smaller expressions. So it's going to be x squared plus 4x and then 5x plus 20. And then I'm going to factorize out of these brackets. So I ask myself what's common within this bracket here, and I can see there's x's. So what I'm going to do is I'm going to factorize out the x's, so x plus 4. So if I expand this bracket, I get this. Factorized, I get this. Next, I factorize the next bracket. I've got 5x and 20. Common factor is 5. So out comes the 5. And then what you can see is that we have a common factor of x plus 4, and what's left out is x and plus 5. So in the most factorized form, this is x plus 4x plus 5. Thus arriving at the factorized form of our original expression. So x squared plus 9x plus 20 is the same as x plus 4 times x plus 5. The way in which we figured this out was, firstly, we split our middle term here into two smaller terms, of which the coefficients summed to give 9 and multiplied together to give 20, which was worked out over here. We then factorize across the two brackets, and then we get the common factor at the front, second factor at the back. So that's the sum and product method. Let's go one more time. B, x squared plus 12x plus 20. I want to split this such that I'm going to get ax squared plus bx plus 20. To do this, I must first figure out what are the numbers for a and b here. I ask the question, what two numbers sum to give 12 and multiply to give 20? I start off with my 12, and that will be 1 times 1 plus 11. Then I change that to times, and that gives me 11. I work my way down, up by 1, so 2, times down by 1, 10, and that gives me 20. So I can clearly see my A and my B are 2 and 10 respectively. Next, I'm going to write these in. So I've got 2 and 10. Doesn't actually matter which order I do this in, works out the same every time. And then I factorize across the implied brackets here. So common factor between x squared and 2x is x. If I do that, I leave behind an x and a plus 2. Common factor here is 10, x plus 2. I can see that x plus 2 is common, x plus 10 is not, so I can say x plus 10 multiplied by x plus 2. If you write it around the other way, it doesn't actually matter either, it's the same thing. Order in multiplication does not matter. So our factorized form is x plus 10, x plus 2. And the way in which we did this is we split the middle term such that the sum of the coefficients of the split was equal to 12, the product was equal to 20. We then factorized across the implied brackets and then factorized the common factor out, leaving behind what was left behind. Okay, let's look at something trickier. We have example 2. Factorize the following expression, x squared minus 18x plus 20. This one is different because there is now a negative involved. It's not harder, it's different. And because of that, what we're going to find is that we're going to go x squared plus ax plus bx plus 80. So it's the same thing, but the numbers that we can get for a and b will be different to what we had before. We still ask the question, what two numbers sum to give minus 18 in this case, and multiply to give 80. Now, because we're getting a sum of negative 18, what this means is that the numbers could be, or one of the numbers at least has to be negative. But looking down, you can see the multiplication is, or the product is 80, which is a positive number. And because of that, there's only one combination of negative numbers we can use. So we have to have both A and B need to be negative, otherwise we wouldn't have a positive product. So because of that, we ask ourselves, minus 18 is going to be minus 1 plus minus 17. So both our numbers have to be negative. Next, we're going to change it to a multiplication, and it will be minus 1 times minus 17 is 17. Working our way down, minus 2 times minus 16 will be 32. And we're slowly increasing, but it's slow. So let's speed it up. Let's jump all the way to, we'll go up to 6, and that will give us 72, so we're almost there. And now that I'm close, I can see it. Let's go minus 8 and minus 10, and that's obviously, so there we have our two numbers for A and B, minus 8 and minus 10. Putting this together, we're going to go plus minus 8 x plus minus 10x. And it's at this point we can do our implied bracket. So bracket, bracket. Next, let's factorize. What do we have in common between x squared and minus 8x? Well, we've got just an x. So we'll take out the x and we'll leave behind the minus 8. Next, we're going to ask what do we have in common between the minus 10x and the plus 8. We're going to have a 10, so let's take out the 10 and leave behind the minus x plus 8. Okay, now this almost looks fine, but there's a bit of a problem. If you look at this term here and this term here, what you can see is that they don't match. They're actually the opposite to one another. You've got x take 8 and minus x plus 8. What we need to do is we need to make them the same. The way in which we can do this is we can flip the signs inside here. So this will become x and this will become minus 8. And in return, we simply change this plus 8 here to a minus. So we flip the sign. And because of that, we now have common factors. Factorizing this out, we get x take 10, x take 8. Therefore, x squared minus 18x plus 80 can be factorized down to x minus 10, x minus 8, or you can put the factors in the other way. Again, it doesn't matter. Now, one of the things you might have picked up as well is this minus 10 minus 8 could have been brought directly from these two numbers here. This step over here and this step over here aren't necessarily needed. You can go straight from there to there if you want, but I do recommend going through the full process for now. Okay, B, let's go again. We have x squared plus x minus 90. We want to split this such that we get x squared plus ax plus bx minus 90. And to do this, we use our scratch pad. Now we start going down. What we are looking for is a sum of 1 and a product of minus 90. So because of this, what we need to do is we need to set our target to sum to 1 and multiply to minus 90. So looking at this, because there's a product and it's a negative, it means one number has to be positive and the second number has to be negative. So one's positive, one's negative. That's the only combination that works. And more so, the sum, what we can see is that the larger number has to be the positive one. Otherwise, we'd see a negative sum. So starting off, we can look at the multiplication, in which case we'll just go minus 9 times 10, and that will give us minus 90. So we're simply picking and choosing the combinations of numbers that will sum 1 and multiply to give minus 90. Moving on, I sub these numbers in, and then I factorize across the brackets. This will give me x times x minus 9 plus, common factor is 10, x take 9. We can see that common factors of x take 9, uncommon of x plus 10. So again, factorized form is x plus 10 times x take. So sum and product method split the middle term into two numbers that will sum to give its original value, but the coefficients multiply to give the constant value, in this case minus 90. Alright, let's step it up one more level. We have example 3, factorizing trinomial expressions to find zeros. So we are combining the concept of factorization and zeros. So factorizing this guy out, let's go for it. What two numbers sum to give minus 4 and multiply to give minus 45? Now, because we've got a negative product, that means one number is positive, one is negative. Because the sum is negative, it means the larger of the two numbers is the negative one. So having a look at how we can do this, the sum is going to be minus 4. What two numbers sum to give minus 4? Well, that will be minus 4 and minus 5, I should say. plus 1. Okay, that works. Let's change it to a positive. So it will be minus 5 here, which doesn't work. So let's move down. Let's go minus 6 times, and this will have to be 2. So one gets more negative, the other gets more positive. That will be minus 12. Let's keep going. And thus we can see that our numbers are minus 9 and 5. Putting this to practice, we can go x squared plus minus 9x plus 5x minus 45. We're now factorizing across two expressions. Common factor in the first one is the x. Common factor in the second one is the 5. Common factors across both of them are x take 9, and what's left over is the x plus 5. So that's the first bit of the question. Now remember, it asked us to state the zeros. Now this one is actually a little bit more straightforward than before in the previous factorization, because when we look at this, it's quite straightforward. You ask yourself, what will make this bracket over here equal to 0? And if you're adding 5, the best way to do that is to reverse it. So rather than adding u, give it negative 5. And for the second bracket, what will make this bracket here negative? Well, if you take 9, then the best way to make this negative is give it 9. So there are our two zeros right there. So in summary, what we had a look at in this lesson was how we can factorize trinomial expressions. The way in which we learned how to do this was using the sum and product method. That being where we split the middle term within the trinomial into two smaller terms. These two smaller terms must sum to give the original value for the middle term. The coefficients must multiply to give the constant term, after which we work our way down by factorizing what's common between both these two new expressions, and then we arrive at our factorized form over here.